All right, so we're going to do a bit of that Q&A that I talked about. We're going to do some notes from the commonly received questions or comments that I got from the survey that I sent out that I'd like to thank over half of you completed. You know, I mean, it is what it is. Maybe next time we can get a little more response rate so I can be a little more proactive in this. Okay, so first just want to talk about some general ideas that popped up and things that I'd like to note before I talk about the physics. So one thing is, please be very specific with your questions. Okay, so I had some people talk about like, hey, I have a question on force and things like that. And if you can say, hey, why did you do that in this video? Or I was doing question 5 in the homework on this worksheet number. You know, why this? You know, because you have the answer key and all that stuff at your disposal. So if you tell me a very specific thing, then I can greatly help. Okay, I can, and I will gladly do generic ideas and generic topics. But if you do have a focus question, please ask that focus question. I will say, please do not ask non-optimal questions. I had several people asking questions that were easily Googleable, like what are the units of work? That was in a video, and you can just type that directly into Google and it's going to give you an answer. Okay, there's nothing wrong with having those questions, but I would like you to have some level of independence, and so that you can get that information from other sources. Okay. Other general thing is that I got a lot of questions that have to do with vectors. Okay, so remember, there's a whole lot of things that are vectors. Forces are vectors. Velocity are vectors. Okay, and so therefore ideas like uh, my brain just died. Momentum is a vector because it has velocity in it. So anything that has one of those elements in it is a vector. All right, so the reason why force is a vector because it has F equals ma. Acceleration is a vector. It cares about direction, which direction's being applied, what's the direction of the net acceleration, and all these things. So direction's a big factor. And so if you see a question that says, hey, you know, it's moving down, what's the velocity? Then the velocity should be negative because it's moving down. All right, so vectors play a big role in everything. Direction is a big key. In terms of homework, there was a question, do we need to actually complete all of the problems on all the worksheets? The answer is no, okay? I'm not gonna be checking for completion or anything like that, so do what, and to the point where you feel very comfortable and confident that you get it right. In all honesty, it reminds me of my lifting. As soon as you think you're done, try and do one more, and that's how you get real growth, okay? Although in lifting, it's usually try and do 3 more. So, you know, if you're like, oh, I can't do any more push-ups, do 3 more. And then you're going to feel the real results. So if you do feel like, oh, okay, I totally get this, then try the next one or try what looks like the hardest one. And if you crush it, you're totally ready for the assessment. And then just go for it. All right. So those were some of the housekeeping items. Also, please watch my videos. Another housekeeping item. I think that on that 15-minute, like, hey, this is everything you need to know video, I had 16 students watch it last time I checked. Now that was like 4 days ago, or that was a lie, that was 3 days ago. But 16 students out of 145 is not the best results. And so I had more than that say, yes, I completed the assignment. So YouTube will tell me exactly how many people watched it. And so I think it was Friday. Yes, it was on Friday. 1 out of every 10 students had watched the video for a grand total on average of only 4 minutes. So you do the math on that. All right. So I do know. I know everything. I'm watching you. I see you. All right. So, you know, keep up, do your best as always. Understand if life happens, totally get it. There's a lot of things going on. Some people, you know, have, or things are going sideways for them, and that's okay. That's life. We'll do the best we can. All right, now on to some of the specific physics topics that did come up repeatedly, and so I will be very happy to discuss this. All right, so this is going to get interesting because I'm going to be typing on the screen as I talk to the screen. All right, I feel like I'm having a fourth wall breaking moment here. All right, so one of the things that was a big topic of conversation was what role does like an angle play when you're looking at power or energy and work and all those ideas? Okay, so one thing I want everyone to remember is that I need to remember to pause the video. So I'm going to pause that so I can set this up for writing because I had clearly forgotten to do that. So let's see if I can pause recording. How do I stop recording? Man. There we go. All right, well, I figured out that I have to do it kind of manually, so bear with me here. Dude, pay no attention to anything that's happening right here. Okay, there we go. We're ready to write. Okay, so again, one of the big topics was how do you know like what role angles play and all this fun stuff. So remember that in order to have work done, you must have a change in energy level. All right, energy. So what that means is if you are, say, dragging something, all right, you are dragging something at an angle. If you are not moving up, okay, you're not moving up, then you have no change in your gravitational potential energy. So that means that this vertical force right here is a total waste of energy, okay? But if you are looking at this and you are actually speeding up, if there is a change in your kinetic energy, then you do have work being done because again, work is change in energy. So you have to ask yourself, hey, is work being done? Well, let's see. Did I have a change in my energy level? Could be vertical, could be horizontal, could be gravitational, could be kinetic. You just got to ask yourself that baseline question. And if the answer is yes, then you ask yourself, well, okay, well, what force made that happen? So if you're pulling something at an angle and you're making it speed up sideways, well, this vertical component is a total waste of your time. All right. That's why if you want to push or pull something, you want to get in line. So it's a pure horizontal push or it's a pure horizontal pull. Anything besides that is just wasted energy. Okay. Because you are just it's a force that's pointless. Okay. So that's one big concept that came through. A lot of kids had questions about like what role does it play? So again, if work is done, then you must apply a force over a given distance, okay, because this is work, but you have to make sure that the force and the distance, these two here, are in the same plane. So if you're walking with something really heavy, then the force is vertical. That's the force of gravity you're working against. But if you're walking, that's horizontal. Those two are perpendicular to each other. So in that case, no work would be done. But if you lift something over your head, well, that force that you're applying is a normal force, push in the y plane, and that would be you moving it in the y plane as well. So therefore, you would have work done. All right. So carrying things horizontally does no work, but lifting them vertically does. So you really have to ask yourself, what is the direction of the work? Sorry, lies. What is the direction of the force? And what is the direction of your motion? Okay, so what distance, what plane are you traveling in? If those two agree, same plane for the force applied, same plane for the distance moved, then work is done. If they are not in the same plane, then you do not have work done, or maybe you only have a piece of work done. So again, if it's like an angle like this, you'd have to break it up into its X and Y components. You love trig, I love trig, we love trig. So you break up to its X, Y components, and then you do the math. You say, wow, okay, well, I lifted it vertically, so I only care about the Y. Oh, okay, I only gave it kinetic energy by making it speed up horizontally, or maybe I dragged against friction or something like that. Oh, okay, so I care about the X in that case. All right, so that really matters. That was a big question that I had a lot of notes about. Because then students ask questions like, hey, what is power? All right, so once you have work and energy, then power is literally just the change in energy per unit time, which is the same thing as the work done per unit time. I should put a delta T because change in time is real. All right, so once you've done this math, it's like, oh, I found the work done. You just divide by time. That's it. You just divide by time. Your units are watts, and you're done and done. Okay, so power is this kind of like last minute addendum. It's more like an appendix. It's there. It's really simply it's just an add-on. Okay, so it's not like a whole new topic or concept. So that was one of the big things that was asked me about was work, power, and energy. All right. The other big thing that I got questions about was this law of conservation of momentum, or I should be very clear, it was actually more the impulse momentum theorem. So let's clean up my board here. So let's erase what I've written so far. All right, so there we go, nice and clean. And so now the impulse momentum theorem states that the impulse, which has a symbol of J, is equal to, well, if you want to apply an impulse, you must apply a force for a period of time. All right, I almost said distance, but that's work. All right, so you want to apply an impulse, then you're going to apply a force for a period of time. What does that do? Well, that ends up changing the momentum, delta P, P is momentum, changing the momentum of an object. And what that really means is you're taking that object, which has a certain amount of mass, and you are changing its velocity. And the big question I got was, Mr. Szymanski, how do you know what to set equal? Like, what is the true equation? Well, in reality, there's a whole multitude of equations. You could say impulse is equal to force times change in time. You could say that impulse is equal to change in momentum. You could say that impulse is equal to an object's mass times its change in velocity. You could say that the force times change in time is equal to a change in momentum. You could say a force times change in time is equal to mass times change in velocity. You could even say that a change in momentum is equal to mass times change in velocity. You've got a few options here. And so the question then becomes, what are your givens? Okay, so ask yourself, what information was I given? Was I given impulse? Was I given a force? Was I given a time? Was I given a bunch of masses? Was I given velocities and changes in velocities? So you really got to make that list of givens. Then based on what that list is, you will choose which two things to set equal to each other. Okay, so it's really up to you. It's up to the scenario. It's up to the problem. And yes, they are all actually equal to each other because they all represent the same idea. All right, so I think those are the main. Let's look at my notes here. Do 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 do. Those were the main things that I had asked as questions from this week's notes. Fun fact, the majority of people chose spoon as the object of choice they'd rather have over a fork. My favorite answer was because you can make a spoon into a fork by just, I guess grinding away at it. You can make a few little teeth, thus making the spork. But unfortunately, a fork will never be a spoon. So I'll probably ask another fun, ridiculous question to see what your life choices are on that one. But that was our feedback. So again, please, watch the videos, ask me your questions. I've basically been on all the time. As soon as someone sends me an email, I'll be dead honest. I think they get a response within the hour, or at least I do the best that I can. Some of you did not complete all the stuff, and that's okay. Like I said, I understand life's going on. Please try and keep up with the work. If you find yourself, you're like, man, I guess I'm done. I'd work ahead. Hey, it's the coolest thing to do is to be able to like say, you know what, I'm ahead in physics and all this stuff. Maybe you watch a movie, maybe you enjoy some life a little bit. So stuff like that. So again, stay healthy, do your best, forget the rest. Do your P90X workouts, people. All right, I got to do one today. I'm avoiding it. No, actually, it's my rest day. Right, today's a rest day. All right, but I should still work out anyways because I got that. I've decided that riding the bike while watching a movie is exhausting, but yet beneficial. So that's kind of my new way of doing things. All right, so see you guys next time.